Good evening, ladies and gentlemen, and welcome to the grand finale. Tonight, we present to you day 12 of the 12 Days of Brilliance. We've invited all of our robotic guests that you have met throughout the 12 Days of Brilliance, but this one you probably have yet to meet. This is our ultimate robot from MakeBlock, and it does some incredible things. In addition to being able to hold a holiday decoration, we have set it up to communicate with this other robot called the MBot Ranger in true brilliant holiday form. Dash, can you play me a tune while I explain our goal for tonight? The goal tonight was originally inspired by these two robots working together, and in fact, we have been working on this video for months. The goal is to use one robot as a sleigh and the other one as a holiday robot dropping off little gifts of holiday brilliance to the two historically accurate 3D printed houses. In order to pull off this robotic accomplishment of brilliance, I certainly could not do this alone. That's why I'd like to introduce to you the brains behind this operation, our engineer in residence at Brilliant Labs, Mr. Tree No. Tree.
Hi, thank you for your introduction.
My pleasure.
Today we are talking about the design a little bit, and I think that the most important point is we create a concept. The concept is very important. You see that it's simple? No, it's not simple at all. So what is the size of this one? And how can you make the sensor to make it? Okay, so now can we start to see how we do that?
All right, let's get started and deliver some brilliance to these houses. Welcome to the on-screen tutorial of Day 12, Secrets Revealed. That was some pretty neat stuff, wasn't it? Watching the MBot Ranger travel along as the leader robot, and then the MakeBlock Ultimate Kit following along, picking up the gift, turning, dropping it off. Amazing. It wasn't simple to put together. There's an incredible amount of coding, and we'd like to take you through that right now in case you want to create your own dual robot leader follower program on your own. So our mission, as it always was, to create this autonomous brilliance delivery system with two robots. And we set out using the exact same problem-solving process as what we did in all of the videos. And here are all the problems we came up with. How do we write code to successfully deliver this holiday brilliance? Well, we need two robots. Both of them have to stay on the exact same track, following the exact same line. So the sleigh robot, the leader robot, needs to stop at a location, and both of them need to resist ramming into each other. The delivery robot, same thing. Stop at a location, resist the ramming, pick up gift, place gift. Clearly you can see that there are 6 different items that we have to code. Wow, that's too much for us to even go through. It took us a long time, 2-3 months. It's an amazing feat of robotic coding. So for you today, we want to limit the amount that we show you to just one, which is a coding commonality between two robotic platforms, and that is both robots using an ultrasonic sensor to stay on the line. Now, this line became an issue. What is the correct thickness of the line that we have to create in order for both the sleigh and the delivery robot, the leader and the follower, to stay on that line? Are we even able to get those robots to drop off those gifts at a precise location? So we had to turn to a concept generation process in order to address this idea of thickness of lines. And as we were thinking about it, we realized that The line following sensor actually functions because it has a pair of diodes. And we quickly realized, and we want to talk to you about 4 different states of these sensors. Both sets of diodes could be on, one off, one on, and both of them off. And that works in our favor because that determines the thickness of the line that we had to put down for the track. We tested 3 different scenarios, and we're going to call them concepts. And we really were not sure which of those concepts were going to be the one that we went with. All 3 of them had advantages and disadvantages. For instance, if we go through these concepts, the first concept had 3 states. And we discovered that this wasn't enough, because what if the sleigh, the leading robot, or either of the robots turned so that either set of the diodes were off course? And so we quickly realized that concept 1 didn't have enough parameters. Concept 2 and concept 3, this idea where we had a thicker track, the default is moving forward. If one set of those diodes went off, it would correct itself. And if both of them went off, the robot would realize, oh no, I have to find the track. Concept 3, similarly to concept 2, had 4 states, but there was an error. If by default there was only one set of diodes keeping it on track and 2 went off, we had to turn back, and 2 were on, but it wasn't working. And so all of this we created in a flow chart and many flow charts. We realized very quickly it wasn't a yes or no, only 2 option answer. We had to discuss which one was going to be the more suitable case. And so I never used this method before, but Mr. Tree taught this method to me, and it was really neat. Very geeky, as you can see here, but we laid out the criteria. How is this decision-making process going to be facilitated by analyzing the advantages and disadvantages of each of the concepts? What we found was that concept 1 and concept 3, so the thin line and then the off-centered thick line, both resulted in a negative, a disadvantageous situation. And we resorted back to concept 2, where it was a stable line, it was easily coded, we were not going to incur more cost, and then finally the assembly was straightforward. Not a lot of disadvantages, not a lot of advantages. It was the safe concept to follow. So after we determined that, we set out to complete the track. And we then needed to consider, okay, we're following the track, then how do we stop at the location? Because one line following sensor was already occupied by staying on track. And so Mr. Tree suggested, we have an extra line following sensor, why don't we use that? And so each of these robots actually have 2 coordinated line following sensors to keep them on track. Now, here comes the good part. We're actually going to share the code with you, and if you have access to 2 robots and 4 line following sensors, 2 for each robot, you can generate your own leading and following robotic system. And here's the code for you. For the leading robot, it's very straightforward. You can see that we're using some complex coding structures like variables and functions, but if you pause the video, create that code for yourself, it will work. The delivery robot, because the delivery robot has to follow, turn, lower, deliver, return, there are a few functions that Mr. Tree used here. The first function is the line following. The second function and third is the turn and return. And then finally, the lowering of the delivery. That's all we have for you. As you can see, there's a lot of planning and a lot of concept generation that goes into this. Project planning becomes very important. Thanks for tuning in.
Thank you very much for joining in on this edition of the 12 Days of Brilliance. Brilliant Labs in honor of the holiday season and this web series, we are issuing a challenge to all of our viewers. If you click on the link below, you will be taken to a form that you can fill out, and upon submission, Brilliant Labs will review it, and then some of our lucky viewers will receive Brilliant Labs support in the new year to complete your project. Thank you for tuning in to the 12 Days of Brilliance.